First, let's get started with vocabulary. What exactly is an equation? An equation can contain letters that represent your unknown number. This is called a variable and is what you're solving for. An equation is made up of terms. Terms may contain a variable or can be a number by itself separated from other terms using an operation sign. An equation says that two things are equivalent or equal to one another. This is shown with an equal sign. But remember, an equation uses an equal sign, while an expression does not. Equations are not the same thing as expressions. Just as there is a sign showing equality, there are also signs showing inequality. Branching off from the equal sign is the greater than or equal to sign. It states that the left is greater than or equal to the right. It also includes the number that is on the right. The less than or equal to sign also works the same way. When using those symbols, an equation becomes an equality. An inequality is used to show that both sides are not equal to each other. It also shows in what ways exactly that they are not equal. These are special symbols. Inequalities have solution sets. A solution set is a group of numbers that will satisfy the inequality. These solution sets can be graphed. A closed circle means that you are including the number, for example, in a greater than or equal to sign or a less than and equal to sign. An open circle means that you're not including, for example, a greater than sign or a less than sign. An example of this would be the inequality x is less than or equal to the number 4. Because you are using the less than or equal to sign, you will include the number 4, because when reading this, x is any number equal to or less than the number 4. To graph this, you would put a closed circle over the number 4 and extend the line backwards from the right to the left. Please excuse my dear Aunt Sally is an essential method of memorizing the order in which you solve an equation. We use this so that we can all reach the same solution. The P represents the parentheses, E for exponents, M for multiplication, D for division, A for addition, and S for subtraction. But remember that in the order of multiplication and division depends on which operation comes first in an equation. Same for addition and subtraction. Brackets can also be used in an equation. They act similar to parentheses. Addition and subtraction are inverse operations. So if I added 7 plus 3 to get 10, I could subtract 3 from 10 to get 7 again. This also works with multiplication and division. 6 times 2 equals 12, while 12 divided by 2 will get me back to 6. How would you solve this equation? Most likely, you would use a thing called the distributive property, aka the distributed law of multiplication. When adding 8 to 28, this applies to another law, the distributed law of addition. Again, the distributive property, or law, states that terms in an expression may be expanded to form an equivalent expression. On a test, you may be asked to simplify. This just means that they want you to rewrite the value in a way that is not as complicated as the original form and is reducing it to its fewest terms. When substituting, you replace the variables with the numbers. You can use this to check your answers. For example, when solving for 2x minus 1 equals 5, you get the answer that x equals 3. To check this, you just have to put 3 wherever you see an x at in the equation. So 2 times 3 equals 6. Bring down the rest of the equation. 6 minus 1 equals 5. So 5 equals 5. So that means you got the answer right. Isolating terms is a method in which you apply the same action to both sides of an equation. The goal is to bring together like terms and isolate the variable. In the last example, I added 1 to both sides because you had to isolate 2x from the equation. So by adding 1 to negative 1, you cancel out the 1 and bring down to 2x equals 6. To isolate the variable again, we divide by 2, which cancels out the 2's. So x equals 3.
If there are 30 stores and 15 of them get destroyed with only 5 being rebuilt, how many stores will be in each of the 4 sections, x equaling the amount of stores in each section? First, you start off with 30 stores. Then you minus 15 to those stores. And then there would be the negative 2 for the section of stores, and since you're taking away from the stores, it would be negative, so negative 2x. And then on the other side would be the negative 5, because it would end up added to the other side from being one of the ones to be rebuilt. Then you would plus 2x, because then this 2x would end up on this side, and it would end up back being a 2. Probably already know that. So 30 minus 15, 15 minus 2x equals 5, negative 5, plus 2x, then you add 5 to 15, this would go away. 20 minus 2x equals 2x. When you add it from this side, I'm going this way. Okay, so then divide 20 equals 4x over 20, and then x equals 5. So from the 4 sections, if you multiply 5 times 4, you get 20. If you plug that in, then it's that.
For our second guided practice example, we will graph the following solution set. 500 minus 25w is greater than or equal to 200. We can't graph the solution set right now because it is not written as an inequality. First, we have to subtract 500 from both sides of the equation. Five hundreds cancel out, and you get negative 300 on this side. Our next step is to divide by negative 25 on both sides because you're trying to isolate the w by itself. So divide by negative 25. And negative 300 divided by negative 25 gets you to 12. So w is greater than or equal to 12. Okay, now that we have our solution set, we can graph. This means that w Any number that is greater than or equal to the number 12 will satisfy this inequality. So to graph that, let's use our number line. We can go from 0, 5, 10, 15. Because this is a greater than and equal to sign, you're including the number 12. So this is included. Go to 12, and so since it's including, we draw a closed circle. Since W is greater than anything of 12, we extend our line towards 15 to show that any solution that is 12 or greater than 12 will satisfy. Okay, so in our third and final example, we will solve for x in the following equation. 6 times 1 plus 0.5x equals 54. Our first step is to use distributive property to distribute the 6 to the 1 and to 0.5, which gets us 6 times 1 equals 6. 6 times 0.5 equals 3. So 3x equals 54. Our next step is to subtract by 6 on both sides to isolate the variable 3x. The 6's cancel out. You bring down 3x and then bring down your 54 by 6, which equals to 48. Divide both sides by 3 to isolate the variable 3x from 3. And you get x equals 16.